Welcome back, everyone, and today we're going to go back into dealing with armatures and animations again. Last time we touched this was back in episode 60, and since I had a month off from work, I ended up going into a bunch of different tangents. So I'm sorry for anybody who's really interested in learning armatures and animations. I end up going through a lot of different tangents and directions after episode 60. So we're gonna go back to armature animations, and we're gonna continue off where we left off, where we're done parsing animation data from gtlf files. So we kind of left off like this with one of our with the test file, and we had this information, and we just took like 2 frames, and then we just started messing around and just animated using some kind of lerp function, and we even used tweening to go back and forth, and we just animated back and forth between 2 different rotation states. Today we're not going to do that anymore. Now we're going to actually use the keyframe information and actually do a keyframe animator. So this way we animate it exactly how the animator or the person who created the animation intended it to animate. So that's where we're going to be working. So it's, this might be more boring. This is more data structure-ish and more back-end, because in the end, you're going to still just have this leg thing just animate back and forth. It's actually same animations that we've been doing every time we use this test file. So yeah, let's look at some quick fungi changes. This is the structure that our gtlf parser spits out. We read this information, and then we're going to create keyframes from it. I think some small changes. I add an items to return, and that's it. It's very small changes to our gtlf loader. It's just storing extra bits of information. vec3 added a lerp function to it from the GL matrix library. Renderable, just a quick bug fix. Just added return this to it, so this way I can set materials and then do other things with the chaining. Very small, simple. And that's really all to the fungi changes for to get this stuff working. So we kind of left off right here, right? So we're outputting all our data, pretty much this stuff that we just saw before. So this is really just all the information that we're getting parsed out from gtlf. These are the animations. So probably don't need that anymore. Now we're going to use a new class we're going to have called keyframes, and we're just going to pass in our animation data that we parsed out and just load it up. So this way it just takes the information and makes keyframe information out of it. And keyframe information is practically almost the same. The data structure can be any way you want it. This is my first interpretation of trying to create some kind of keyframe data structure. I'm going to create basically it's an array, and a keyframe, in case you don't know, is a state in a timeline. So during animations, you kind of have a timeline, and you have like little points in time that define a certain value. So if like within 1 second, you're supposed to have a rotation of 45 degrees, and at second you're supposed to be at rotation of 90 degrees. Between that time, when you're like going through the timeline, you're going to lerp between those 2 values, between those 2 keyframes. And when time goes past that, you go to the next keyframe. So you always end up lerping between 2 keyframes. So this might not end up being the final structure, but it's kind of something bare bones and simple just to get started. So simply, it's just frames are just an array, and each item is going to be a simple struct, which has a t, which is time for, I guess, the keyframe. Do I still have it? So in the samples, we get time. So that's like 0.04 seconds. This is 1.04 seconds, and that's 2.08 seconds. So we're going to store those t values here as well. So we're just going to keep time. It's probably not the best idea to call it t. Maybe time or something like more descriptive. But like I said, this is more of like a proof of concept structure we're doing today. It's something very bare bones, something to get started. So we can do some keyframe animations or start building up some keyframe animations and animators. So we can actually start creating 3D characters that we can control with WebGL. So I'm trying to make this as generic as possible because you can use keyframe animations to keyframe anything really. You don't have to keyframe just armatures. So that's why I'm kind of keeping things very generic. So that's why I have like item name and things like that. So we're going to store time. And then within time, we're going to have another array of items. And items can be, a cube or a sphere or any kind of renderable, basically. So anything, so basically just our main object that we want to animate. And then within that, we have an array, but it's a named array. I normally will call these a dictionary. So these will be a dictionary because I want to be able to loop them easier than a structure. So it's basically a dictionary where we always store what property we're going to animate. So let's say item name will be square, and I say I'm going to animate the translation. That means I'm going to move that square between point A and point B depending on the keyframes we're currently animating. So that's basically the main structure we're doing. We store the max and min time of the animation. So this way we kind of know the starting and end point. So when we're building up our keyframes, we check to see, we just save the max and min. So our starting point really is our load. So during a load, all we're going to do is just loop through the data and just call our function AddFrame. And we kind of pass in our time, the name of the object, the name of the property, and then the value that we're changing from that property. So the main really butter function is AddFrame. So what we're doing in AddFrame is that we're going to do more than just add a frame. One of the first things we're going to do, we have to find if there's a keyframe that already exists with the exact same time. So the first thing we're going to do is we're going to loop through, check every frame, find something that equals t. If it equals t, we check to see if that item already exists, because maybe we want to animate more than one property per item. So we check to see if that item exists on the list for that keyframe. If that object exists, doesn't exist or something, we just create for it, and then we add a property to it and the value. Because I said we can, like the structure here, like I can take a square or a cube, and I can animate its translation, and maybe I want to animate its rotation. So you might want to be able to do more than one property change at a time. So there we go. If the frame does not equal the exact same number, we check to see if the t value is less than the t that we're looking for. So we're trying to find the index of the minimum index. The reason why we're doing this is we're going to loop the whole thing. And at the end of this loop, if we did not find a keyframe that exists with that exact same time stamp, we're going to insert a brand new keyframe after the minimum. So the idea is that when we add frames, we're going to take the extra step of actually sorting it on insert. Instead of inserting all the frames and then doing a sort, I want to sort as we're inserting. The thing is that sometimes it's a little slower to insert in real time. If I was doing something like maybe C++, it may be better off loading everything first, then sorting it afterwards. For obvious reasons, but for JavaScript, it's easy to kind of just insert in the middle. So why not just make it easier for us in the long term? So yeah, if we're building a new frame, we create our data structure, and then here if the minimum is not equal to -1, we use the splice command. We just say min plus 1. We say 0, and then that frame data we want to insert, and that automatically just inserts that frame at the right place that we deemed is sortable, the right place for it to be sorted. Else we just push to the very end. Like if for some reason we can't find anything smaller, that means the current frame is the greatest time. It's the time most further away. And then at the very end, we check to see the time that we're inserting. It can compare to min and max and save the correct min and max. So like I said, while we're adding a frame, we're going to sort it on insert, and we're going to check to see if it compares to our mix and min and max time. And that's really all it is to our keyframe data object. This is all the bare bones you need to really just to kind of manage that data. And like I said, you don't have to sort on insert like the way I'm doing it, but it takes away that extra step, because at this point, if you're going to build keyframes manually, then you always have to remember the sort at the very end. If you're building like a function like load from whatever, some kind of load function, when you're all said and done, you can then at the very end say sort keyframes, which would be easier. So it really depends on how you're building this. It might be like like I said, if you're going to do manual, you might don't want to always remember the sort at the very end, because if you don't have it sorted, it makes animating a little bit more difficult. It's like it's faster just to make sure everything's sorted by time, so you can always grab the current frame, and then the next frame is correct. You don't have to go searching for what the next frame is, because the next frame is the next element on the array. So it just makes data handling a lot easier if we just make sure it's sorted. So like I said, there's different options you can go about it. But today I'm going to sort on insert. Sort on, like I said, it's slower, because for every keyframe you insert, you kind of have to rebuild the array, and that's what's happening in the background. An array is being kind of rebuilt. And the next thing we have is I have two things. I have Animator and I have Armature Animator. What we're going to really use is this one, but we're going to go through this one first because I wanted to make a bare bones, very simple Animator object that anyone can kind of take as a starting point to build an Animator tool for keyframes. It's very simple, because when it came down to doing armatures, I needed a lot more things and it becomes more complicated. And on top of that, in the end, I might end up having two animators. I might end up just having a keyframe animator, which uses just keyframes, and it just uses whatever objects and whatever properties you have. And then there's going to be the Armature animator, which also uses keyframes, hopefully. If not, I might end up having like a different object. But since armatures have so much bones to animate, I want a dedicated animator object for it to streamline it as much as possible. Because, like I said, when you're dealing with bones, you can have up to like 70 bones being animated. Like if you have fingers, you have feet, legs, arms, neck, head, arm. There's like a lot of bones. Like especially by the time you get down to the hands, you got like 3 bones per finger. You got 5 fingers. That's 15 fingers or 15 bones just for one hand. When you're dealing with 2 hands, you got 30 bones. 30 bones just to deal with 2 hands. So you're gonna go through a lot. So like if you're gonna animate, you might want to make that animator for an armature as streamlined as possible. Take out any garbage that you don't need. So that's why I might end up having 2 different animators in the end of the process. So we're going to go through the main animator first, which is a simple idea. So the animator, we're just going to pass in our keyframes, and we're going to keep track of, is it running? And every time we start an animation, we grab time. Now, there's 2 different ways we can go about doing this. Right now, I'm going to start off using the system clock, basically, to control animations. Now, the only problem with me doing that is that I can't not control the speed of the animations. I can't make it slower or faster. Down the line, I will probably fix the animator to be independent from the clock of the system, where it kind of tracks time by itself. It'll probably use delta time to calculate how much time has passed, and then using some type of scaling value to slow down or speed up the time. But for right now, like I said, instead of doing all that extra complexity, I'm going to do something that uses system time. So when the time starts, I use since start fungi that time. So since time, okay, I'm sorry. I'm like, why am I doing that? I was okay. Since time saves everything in the milliseconds, and it's the start of basically the web page, basically the start of the application. So time is basically 0, and it's an actual time, but we take that time, but that time constantly moves forward, so it's always moving forward. So I'm sorry for the pause because I'm like thinking, and so at the start point, every time we do an update on a frame, we grab the since start, and since start, like I said, is time that keeps going forward, and then we minus from start time. That kind of gives us our offset, so we know how much time has passed. So we know current time, like how much time. Has it been like 15 milliseconds? Has it been 20 milliseconds? Has it been 2,000 milliseconds? So that's when I say we lock ourselves to the system time, essentially, because we're using actual time to actually kind of control each frame of animation. Okay, so, and we're also gonna do a shortcut for frames because I hate doing these long structure names. So that's basically kind of just an alias. So when we're animating and we want to animate, so the first thing we're gonna do is I guess check to see if we are at the end of animation. Like if we're at the end of the animation, we want to loop back right to the beginning. So we kind of loop everything. So if current time is greater than the max time, remember I said we were trying to keep track of the maximum time keyframes are. This is the reason why. It's because we want to know when we're done. And when we're done, we're going to reset the start time to whatever the current time is, and reset all the indexes from 0 and 1. Those are the keyframes, and the time that has passed is now reset to 0. So like this whole section really just, if we're at the end of the animation, go right back to the beginning of the timeline. Now the next thing is we're going to compare to make sure that we are currently in the right, if we have the right A and B keyframes. So we're going to check current time. We're going to take the current time that we have, and we're going to check to see index from, index to, A and B, and make sure that CT lives between it. If it does not live between it, we're going to go search for the keyframe that our current time lives within. So that's all we're doing, and then we save I. And we say I plus 1 because everything is sorted. That's the reason why I said if we do everything sorted, it makes things a lot easier because we always know the next one will be B. As long as we get something that's equal to or greater than our current value, we know the next one might be it. So we always have to check to see if the second one is greater than, and then the A is always less than or equal to. So I guess a quick recap is that we check to see if we need to start the loop over again, and then make sure we are in the current. We have the two keyframes selected that are correct. Once you have the two keyframes and you know what time you are in, then all you got to do is normalize the information. So you take the offset between the two data, between the 2 points of time. So that's T2, T1. So you kind of normalize the time, and then you take current time, subtract the first time, which kind of normalizes it as well, and you do a division, and that creates a value between 0 and 1. So we basically end up normalizing current time and the time between the two keyframes. Once we have T, we can then animate. We can just say we want the T value of rotation A and rotation B. Then you can use a lerp function, put in rotation, or translation, and say, here's my two positions, give me the T position of that. So that's what this is doing. And with all said and done, so let's say, like I said, we set up our keyframes, we load it, we have our plain old animator, and we pass our keyframes, and we click start, and then we'll just do an update. Now this is not going to do much, quick refresh. All you're going to do is see data. But if you can kind of focus right over here, you have 0, 1, 1, 2. As you can see, time is bouncing back and forth between frame 0 and 1. Then it goes to frame 1 and 2, and then back again. And I think this one tells you what t value is that you're currently in between those two keyframes. And I think this shows you the time of keyframe A and keyframe B. So this is the bare bones essentials, I guess, for basically an animator for a keyframe animator. So you have your keyframe object with all its data, which is simple bare bones, and then you have your animator that kind of just makes sure it's within the right time, and then kind of just gets the t value between the two. And then from there, it's up to you to kind of use that t value in any way you want to. So let me... So now we're going to... Now that you understand how the animator works and how keyframe data is all set up, now we can go look at the Armature animator. And it's essentially the same thing. So now with that animator out of the way, you'll notice it's the same thing. Now, like I said, there's a couple extra steps we have to do. We're not only are we saving the keyframes, we're also going to save the armature because we want to update the armature. So this animator is going to update all the armature information, all the bones, all the joints inside the armature. Now, I didn't comment this, but item link is that we need to be able to link an item that we're animating in the keyframe information to the actual joint. The reason why I like I said, I should have commented this out a little better. But this is what this function does. What it does is it creates a quick index from keyframe items to armature joints. This allows for easy lookup when updating the animations. So by pre-linking everything, you save time during animations. So let's see if I can shrink this down. So here's our keyframe information, and we have item name. The thing is, all we have is the item name. So we just take that item name, we quickly search the armature to see if there's a joint with that name, and then we say, okay, well, this name is tied to that armature. But the thing is, what we're going to do is we're going to tie that name to an actual reference to the armature joint. So this way, we can just point right to it and update the data right away, very quick and easy. So we're going to have that pre-setup that we kind of have to do. And that's all what this function does. It just loops through all our keyframe, and I think a keyframe has our item names. And it just tries to find all the joints that have those names. And if a joint doesn't equals null, you're going to get an error saying, okay, you know what, we're animating a joint that doesn't exist. So if you see this kind of error in your log, you know there's something off. And that might be okay. Maybe you might be using an animation and you might be using all the joints, so it's okay. But for now, I'm giving you I'm putting like an error, but I'm continuing. I'm not stop processing, because like I said, you might not care. Maybe you just want to animate just 2 or 3 joints, or it's okay that certain things are missing because you don't need them. So yeah, it's search the joint, get to the joint, and then attaches the name to the actual reference. So this way we can access it right away. So that's like one of the it's an optimization thing. So during so when you're trying to update a frame of information, I don't have to go to Armature and say get joint, because that means I have to go through a loop, and if there's 70 70 joints, that means I have to go through every 70 joints. I have to do 70 searches. Like I have to loop through 70 times. So it's kind of a waste of processing to do that at every frame of animation. So if we can pre-link everything, link our armature data to our keyframe data, it'll just save ourselves a hell of a lot of time. We have our start function, which is the same. We have a function here to find keyframe between t, which I think the other animator had it. No, it doesn't. I took this function, this chunk of code from the update, and made a function out of it. That's what I did. So that's what find keyframe between t. So like I say, that t value, and it just searches to find the correct two positions. So it's the same for loop, but I made it into its own function, so it's out of the way. Because the update function is kind of long, so I just wanted to pull things out that I don't need. So yeah, it's a lot of the same thing. We're checking to see if we need to restart. This checks to see if we are between the two keyframes. And this is all the same thing. And we're getting the two values, and we're normalizing the value. And then we kind of just loop through all our items, and we grab the properties that we want to modify, I guess. Oh no, we get the keyframe A and keyframe B information. Oh yeah, we're gonna get this part, item data. So this way we can get its translation and its rotation. So and I save the link too. So this way, when I grab the rotation of item A and item B, and I give it time, I then say automatically save it into the rotation of the linked object, which is really the joint. At some point, I'm actually rename this to joint, so it makes more sense. I try to be too generic, especially since this object is meant to be very specific. So I was a little bit too generic in doing this. But like I said, this is the first prototype version, and it's no big deal. And same thing with position. Now, the one thing we really should do is pre-process a lot of the keyframe information, and see if we even need to do animation. Because I'm lerping between position or translation, and there's no change in translation. So I'm actually doing a bunch of math here when there's no need to it. To me, it's feels like when you're building up the keyframe, you need to, at the very end, you maybe need to go in and double check everything. Go through everything and check to see if there is a change at all. Like if every single keyframe, the translation stays the same, remove it. There's no point in having it. So this way, when I'm at this point, I can just say, does translation exist? No, don't lerp it. Like I said, there's more things to optimize it that we still need to do down the line. But like I said, this is the bare bones. This kind of gets us started. But we really should check, because when we're doing Armature, most of the time it's going to be rotation. Sometimes there will be some position changes, and very rarely there will be scale. But sometimes scale can be used for animations. If you want to make someone blow up or something, you make them expand, and you want to animate that in an Armature. Or like a helmet gets big for some reason. I don't know. Gets inflated or gets huge. And so when we do our lerp for our quintorian, which is our rotation, and our vec3, which is our position, at the very end we tell Armature to update, because we updated all the bones, all the joints, and now updated, which then creates all the dual quintorians that gets passed over to our shader that then actually animates everything. So if I click save in Animator, everything should be fine. Refresh. And that's it. And this is what the animation is supposed to look like. This is the speed and the actual animation that is saved in the GTL file that's supplied by Kronos for testing when you're creating parsers. And that is keyframe animations. And like I said, it showed you how you can kind of take the basic animator that we have, which does the basic math that we need, and how you can kind of apply it a little bit to things. We have lerps. And like in a previous, remember in the episode 60, we used tween. So it's up to you how you want to animate it, because once you have T, and then you have your A and B positions that you want to get to, you can do whatever you want with it. Like I said, for here, I'm just using lerp. A lerp is a linear interpolation. I do have something here where I'd say, is it better to just make all the keyframes into dual quaternions and then lerp that? Or is it better off to keep everything separate as rotation and translations, then set everything in dual quaternions, which is basically what we're doing right now. It's been a month since I've, actually it's been about a couple weeks since I've made this thing. I'm actually like 3 videos behind so far, so I got to try to do a lot of recording this week since I've been doing a lot of programming the last 2 weeks. So I've been thinking about this, and I really think there is no. I don't know. Like, converting everything to dual quaternions then means that I need to always animate between the 2 points. To me, I was like, even though with all the thinking, I was not sure. If all the animations I'm doing is rotation only, then maybe it's better off keeping it separate. So this way, I only animate the rotation when I only animate translation if I really need it. And then that means I'm only going to lerp quaternions, which would be better than lerping a whole dual quaternion. The math, I think, is a lot bigger to lerp that. So I think probably, but like I said, overall, probably better off this way, just keeping everything separate. Because like I said, most animations are all just done with rotations. There's very little. I don't think there's a lot of translations. There is translations when you're moving it, like if you're actually moving the character, making them fly. But sometimes I think that's root animations, and most often you take the root animations off. You turn them off or something. Like I know when I was doing Unity, I always end up turning them off because they end up screwing up my animation. So I always took off root animations off. So that means any translations that was done at the root bone no longer didn't apply. So that's why I'm kind of thinking like I really don't need to keep them together most often. So I think in the long term, maybe it's better off keeping them separately than converting everything to dual quaternions and then lerping between them. Prove me wrong. I'm pretty fine. Like if you guys know if it's like the only real way to do it is to build 2 animators. And that has like a really hard, like very heavy animation, and see which one has the best frame rate. That's basically the only way to really test it. And maybe down the line, if I have a good, good enough stuff around to really put that together, maybe I'll do that. I'll set up 2 different animators. One will be dual quaternions, one will be separate, and see which one rotates better. And the animation I wanted that only has rotation. So this way, like, does adding everything together as dual quaternions and then lerping the dual quaternions, does that slow the process down? Or like I said, it's better off just doing the lerping on rotation, leaving position alone, and then just updating the armature with the rotation, which then creates the dual quaternion anyway, for me in the end. Because it needs to do, the armature needs to do extra steps too. It needs to then multiply by the offset. If you remember when we're doing bone animations, you have the what's it called now? Shader primitives. I think it's entities, armatures, add joints, bind pose. We have our bind pose that is like the starting point of all our bones. So. And at the very end, we kind of need to, once we have the dual quaternion, we kind of have to multiply it by our bind pose for that bone anyway. So we still have to do more math on it anyway, because that offset then actually does the actual animations. So I guess a little refresher on armature animations in case you don't remember. So yeah, I guess I should leave it at that. I should have explained everything about keyframe animations. I'm so sorry that's taken me a month to continue it. Like I said, I took a month off from work, and then I ended up doing all these other videos instead. But we got voxels, which is great, which is going to help. And we did the shield thing. That took a lot longer than I thought. I thought it was going to be like a 2 or 3 day thing. It ended up taking me 2 weeks. So that killed a lot of my time. But yeah. But it's pretty cool though. That I like some of the effects that we got from this, and it does it's very useful. Because we got deferred rendering now and everything else. So hopefully that will add to more lighting. The next video is not going to be about armatures. I need to go back and essentially redo Bendy. I'm going to not do all the vertices over, but I'm going to do the armature. I need to fix part of the model. I want to detach the head from the body, and then redo the armatures. The armature for the model. I've been playing the lab a lot, and I kind of just sitting there with my Vive goggles on and just staring at Bendy. Certain parts of the lab, you can kind of see all the Bendies move, and I noticed certain ways they animate that realized that the head is not attached to the body. The head actually detaches from the body, and there's some really cool, funky animations that Bendy does in the game, where in my model they're attached, and I can't do it. So I got to go back and fix Bendy so it's more in tuned to how it is in the lab. So this way I can do some of those animations myself down the line. So I need to do a lot of that first before I can continue on with more armatures. So the next step would be to get Bendy with a walking animation and have him exported and imported, and fixing the keyframe animator to actually have it animated with walking. So that'll be the next animator or armature animation video, would be to get Bendy walking. So that's going to take a lot more work to kind of get done and going. And until then, I have other things I can do. I do have one more kind of challenge video I finished the other day. If you go through Twitter, you'll see it. So like again, if you're really interested to see what I'm currently working on, Twitter is the best place to be. Yeah, that's about it. I'll see you guys in the next video. I'm not exactly sure what it's about. I forgot. But hopefully it'll come out this week. And please like and subscribe. And thanks for everyone for subscribing. I'm already over 700. That's awesome. And the 1 year anniversary of the channel is coming up in a week or two. So I'm trying to figure out what little thing to maybe do or just make, I don't know, or make for the 1 year anniversary. So yeah. So we've been doing this for almost a year, and yeah, I don't know, whatever. So I see you guys in the next video. Please like and subscribe, and thanks for viewing.